Hey everyone, welcome to Math Talk. I'm your host, Brian Eisler, and today I'm going to start a series on some popular questions on the GED math test. Now these questions may not be exactly like the ones you're going to see on the GED, but they're going to be similar to the types of questions you'll see on the GED. And so we're going to start that series with looking at some non-calculator questions. So let's get started. Here we have some examples of some expressions that you're asked to simplify. This is pretty common on the non-calculator section. It's important that you know your rules for multiplying and dividing numbers with different exponents, and also knowing your squares and your cubes. And so the first one asks, what is 6 squared minus 3 squared? And so 6 squared is 36, 3 squared is 9, and 36 minus 9 is 27. All right, next one, 2 cubed. 2 cubed is like 2 times 2 times 2, which is 8, and 3 cubed is 27. You add them up and you get 35. Okay, so pretty straightforward addition and subtraction. The next one asks you to multiply two numbers that have the same base with different exponents, and there's a little trick to doing that. And the trick is whenever you have two terms with the same base, which in this case is 4, with different exponents, the trick is to just keep the base the same and add the exponents together. So 4 to the 2 plus 3 is 4 to the 5th, and so your answer choice is B. All right. Similar to that, when you're dividing terms with the same base and different exponents, you will go ahead and keep the base, but this time you're going to go ahead and subtract the exponents. So 7 minus 5 is 2, and your answer is 8 squared. Now, I don't see 8 squared in my options, but I know that 8 squared is 64, so the answer is A, 64. All right, let's keep going. This one asks you to find the expression that represents the distance between the 2 points on the number line below. So number lines are pretty common. The key to keep in mind for this is that distance between 2 points has to be a positive number. Now, one of the things you can do is you can go ahead and just, count the distance between, the point on the left and the point on the right. And if you do that, you're going to get 1, 2, 3, 4, 5. And so you need to find the expression that represents the value of positive 5. So if you look at the different options, you look at A, the absolute value of negative 1 minus 4 is the absolute value of negative 5. And the absolute value of any number is the positive value of that number. So absolute value of negative 5 is just positive 5. So this looks like a pretty clear candidate for the winner, but just to be safe, let's look at the other options. Negative 1 minus 4 is negative 5, and so distance can't be negative, so that's out. And the absolute value of 4 minus 1 is the absolute value of 3, which is 3. And that's not far enough. So like we had guessed, the answer is still A, which is absolute value of negative 1 minus 4. And that's really the trick to find the distance between 2 points on a number line. You just take the absolute value of the difference between the two numbers. And there you go. So let's keep going with some other examples. Determine the product or quotient below. So multiplying or dividing decimals is pretty common because it is something that asks you to use certain rules for multiplying and dividing decimals. When you're multiplying decimals together, you're going to set it up like a regular multiplication problem. You're just going to remove the decimal points. And there's a trick to handle the decimal point after you've gotten your answer. So I set this up like this. I just have a standard multiplication problem, and I'm going to go ahead and multiply like normal. So in 23, I'm going to multiply the digit 3 times each of the numbers. So 3 times 5 is 15, carry the 1. 3 times 2 is 6, plus 1 is 7. 3 times 3 is 9. All right, now I'm going to go ahead and multiply the 2 in 23 times all of my digits up top. First, I got to carry the 0 down, and then I can multiply. 2 times 5 is 10, carry the 1. 2 times 2 is 4, plus 1 is 5. And 2 times 3 is 6. All right, now I've multiplied all my digits. I'm going to go ahead and add the two numbers together. I get 7475. All right, so obviously 7,475 is not my answer because that's way too big of a number. but I need to apply the rule of the decimal point to this situation. So in any number, there's an imaginary decimal point at the end. And so you want to go ahead with your decimal point answer, you want to go ahead and count the number of digits that are after the decimal points and your original numbers. In this case, there's 3. And so that imaginary decimal point is at the very end of my answer. And the trick is you're going to move the decimal point to the left however many digits there are after the decimal points in your original numbers. In this case, there are 3 digits, the 2, the 5, and the 3. And so I'm going to move my decimal point in my final answer to the left 3 spots. So 1, 2, 3, 7.475 is my final answer, which looks like a much more reasonable answer for a number a little more than 3 times a number a little more than 2. Okay. So let's look at the second example, 4.5 times 1.25. Now in this, I actually am given 3 answer choices. I'm not even going to do any work for this because I'm going to use logic to use process of elimination in my answer choices. So I have a number about 4.5 times a little more than 1. So if I look at my answer choices, 48.5 is way too big of a number. So I know right away that's not an answer choice. If I look at B, I have a number 3.25. Well, I'm taking 4.5 and multiplying by a number that's bigger than 1. So my answer choice really needs to be bigger than 4.5. So 3.25, 3.25 is clearly out, which leaves option C, 5.625 as the only possible answer choice that I could have. And so process of elimination, C is the answer. All right, my last one asked me to divide decimals. So 12.4 divided by 0.125, I've just kind of rewritten it in standard division signs. And the trick to dividing decimals is the number on the outside, you're going to go ahead and move the decimal point all the way to the right until you basically don't have a decimal anymore. And however many digits you move the decimal to the right, you're going to also move the decimal on the number inside the division sign that many places as well for consistency. So I'm going to go ahead and do that now. And so I'm going to move my decimal point 1, 2, 3 places to the right. And you notice on the inside, because I kind of ran out of digits, I've added a 0 for every space that I've moved the decimal point. And that's a pretty common practice. You need to make sure you add those zeros for place value. And now that I moved it all the way to the right, I'm going to go ahead and bring my decimal up and kind of clean up the number on the outside. It becomes 125. Now, you need to see how many times does 125 go into this number. And so, 125 doesn't go into 1, doesn't go into 12, it doesn't go into 124, almost, but it goes into 1240. And so how many times does it do that? Well, if I were to say 10, 125 times 10 is 1250, which is almost 1240. So I know that it has to go in there 9 times, which is just under 10. Now, I multiply 9 times 125, and I get 1125. Now we need to go and subtract these two values. And when I do that, I'm left with 115. Now because I still have a 0 in a place value, I need to go ahead and bring that 0 down and repeat the process. How many times does 125 go into 1150? Again, if I were to multiply this by 10, I'd get 1250, which is a little more than 1150. And so I look at the next number down, which is 9. And I know that's the right answer because I know that it gets me 1125 just like before. So 9 times 125 is 1125. I subtracted 2 and I'm left with 25. Now I still have this remainder here, so I need to go ahead and continue to perform the operations so I get a remainder of 0. Now I don't have any digits left over, so to accommodate for that, I'm going to put in a 0. There's a little space here because I'm basically just making sure that I'm doing it after the decimal point. Because I've already reached my decimal point, everything after that is going to be a result that happens after the decimal point. So I add a 0, I bring it down. How many times does 125 go into 250? Fortunately, it goes in there twice. And 2 times 125 is exactly 250, So when I subtract the 2 off, I get a remainder of 0. So there's no other operations that need to happen. I just need to find my final answer, which is 99.2, or to kind of clean it up, 99.2. So one of the things that will come in handy is actually knowing the fraction equivalent for decimals. For example, 0.125 is 1/8. So really I have 12.4 divided by 1/8, which is the same thing as 12.4 times 8. And if I do 12.4 times 8, I actually get 99.2, which means my decimal division is correct. I hope this helps as you get to questions on the non-calculator portion of the GED math test. Be on the lookout for the next video in this series when I look at how to write expressions. And as always, thanks for watching.